So here's a video for Euler's method on the GDC, and this is for a coupled system. Paper 3, this is the answer for part DI. So you've got the two iterations of Euler's method, where to find the next one at xn plus 1, that's based on the previous one. And we're told in part 2 that the initial populations for x is 100, and for y is 100. And we're supposed to calculate with a step size of 0.2. That's why this is filled in here for h into the formula for both of them. And we're supposed to calculate, it says start, we're supposed to calculate for when t equals 1. So that means we're going to have to do five iterations or 5 steps, do Euler's method 5 times essentially. And doing this by hand is really tedious. So you're supposed, and this part's only worth like 2 points, basically for the answers. We're essentially finding, what's x going to be after 5 iterations? What's y going to be after 5 iterations of this recursive sequence? So on the GDC, mine's a little bit different than the new ones, but some of you have these old ones, so this will work for you. And I'll show you the difference. So if you go to mode, you have to change from function mode to sequence mode. And when you do that and you click on the y equals button, you'll notice everything's different. So the new calculators, this already says un plus 1, and mine says just un. So there's going to be a slight difference here. Right here is where we type in u is x and y is v. So here's where we type in the first line of the equation. I type in x, n, but instead of x, I have to type in u. So I have to say second u, and now I have to put in parentheses. So un would just be u, and when I hit the x button, it makes the n. So for the new calculators, you can just type in n, but for mine, I have to do n minus 1 because I want the previous. So the way that Euler's method's set up is to find xn plus 1, you want the previous, which would be xn. But my calculator says the next one is un already, so the previous would be un minus 1. So if you have an old calculator, you type in n minus 1 instead. So then we do plus the step size, and then just copy the rest. xn minus 1, so I have to say un minus 1. And then I have to divide by 1,000 because that's part of the formula. Now close parentheses, keep going, and the rest of it says 2,000 minus 2,000 minus, where is it? 2,000 minus xn. So minus un minus 1. And then minus 2yn, so minus 2, and y is v, so we have to say second v, and then I have to do n minus 1. And now I want to close all my parentheses. Okay, now this part where it says n min, that's where we type in the initial population. Whoops. And actually, before I need to go back and change this initial one to 0, not 1. And this is just going to determine, so this is going to make it so that I count this 5 times instead of 6. So now Vn, now's where I plug in the second line of the equation. So Vn is Yn, which is V. So Vn, I have to do n minus 1 because I want the previous, plus 0.2 times, and then I do Yn minus 1, so Vn minus 1, divided by 1,000. And then times 3,000 minus, now it says 3xn, so I have to do 3un minus 1. And then minus yn, so I have to do minus vn minus 1. And now I want to close all my parentheses and enter in the initial value for y, which is also 100. Now all I have to do at this point is check the table, second table, and it's going to calculate everything for me. That's going to tell me x x1, x2, x3, x4, and I want x5 is going to be the answer. So sometimes it takes a while, especially this version of this calculator can take a while, even just 5 iterations of this. My actual handheld calculator told me that, I'll just write it down, that so if you've got n and then it gives you like this eventually, and then Vn. So after 5 iterations, we've got 318.57 for Un, which is x. And then we've got 617.02. Let's see if... Now, I don't think this one can actually do it, but this is what my handheld calculator told me. So that's why on the mark scheme, it says x is about 319 because they're rounding 3 sig figs, and y is about 617. Sorry, my squiggly approximate. I'm in a bad habit of always writing equals, but these are approximations, of course. Okay, so hopefully that helps you figure this out. I'll go back. I don't think this calculator is going to handle it. So that's it. That's how you do it. For the next part, you need to do even more iterations, so the long term. So you just need to scroll down on your table, or just enter in a really big number into the table and see what it calculates in the long run. And that might take a long time. So if you keep going and you do like 100 iterations, just type in 100 into the table for n and see what you get here. And mark scheme says this one's going to go down to 0 and this one's going to go up to 3,000. So that part should be pretty easy. Just don't type in too big of a number because it will make your calculator go really slow. All right, I hope that helps.